actually like doing like algebraically instead of just doing graphical stuff. If you remember, taking derivatives, we had the power rule. So bring down the n, and then you leave the x and reduce the power by 1. So integrals is the opposite. Integrals and antiderivatives are the same thing. So where it says antiderivative, you might want to also write like integral. Same idea. So the rule for these, it's basically the opposite of this. So you're going to add 1 to the power, and then you divide by the new power, or you can multiply by like 1 over the new power. It's supposed to say n plus 1. I'm just trying to make it so you can see it. So that's the rule. But like once we started doing derivatives, how often did you guys think about this? Like not very often. So it's the same idea. Like it's there, we know it, but we'll just kind of talk through it and you'll get used to how to do it. So let's look at the examples. Can I like erase that and move the screen? Alright, so before I should have told you that I had you do this before I even gave you a rule. Give me a function that has a derivative. We're doing antiderivative. Tell me a function that has a derivative of x squared. Just give me an example. One answer is 1/3 x cubed. So I don't know if you followed the rule or not, but we can talk through that. You add 1 to the power, so now it becomes a 3. And then you multiply by the reciprocal of the new power. So you could also write it as like x to the 3rd over 3. But the way I think it's easier to do this. So you add 1 to the power, you multiply by the reciprocal of the new power. So I don't know if you use that, if you just kind of thought through it. But if I took the derivative of this, wouldn't I get x squared? Because 3 times 1/3 is just 1 and then x squared. What else? What are you?
No,
X squared, give me another function that has x squared as a derivative. We are not proceeding with class until someone can do this. I'm just going to go pop squat over here. Maybe we'll do it.
Okay, so now that the morse barbecue, we need your help.
Yeah, we actually got stuck.
I'm not proceeding until someone can answer the question.
Okay, the idea is we need to find something that if you take the derivative of it, you get x squared. So we figure out 1/3 x to the 3rd power. We did another one.
I just read a whole like
What?
Alright, sit down. Sit down, I'll catch you up.
and then a girl told me her mom was in the hospital.
Ooh. Alright, so I'm doing this again for you guys. Are you ready or not yet?
Yes, I'm so ready.
Are you ready? Okay. So x squared, I'm trying to find an antiderivative of x squared. So that means something that if I took the derivative of, I would end up with x squared. So people said 1/3 x to the 3rd. So let's just check that. If I take the derivative, so like 3 times 1/3 is 1, leave the x, reduce the power by 1. So do we agree that the derivative of this is x squared? I said, what else has a derivative of x squared? And everyone just stared at me, and I'm just going to sit here until someone figures one out. Let the two new people think for a second before you shout it out. I think you might have it. Let's do that. If you think you have it, like raise your hand. This way we won't like spoil it for anybody else.
Let's go, genius.
Write it down. Let me see if you're right. Heck has got it. Yeah, here's the next clue. There's infinite number of possibilities.
You can't think of one.
Does that mean that I'm smarter than that?
Congratulations, Zach.
Think about it. You take
Wow,
it.
that's a really nice one. Now, think about it.
Swim faster. That's like that's the same level of advice.
Don't crash.
Just like there's part of a derivative that never matters. That you can like change and it won't change.
No, stop.
Well, he's trying to help you.
Really?
Yeah.
Okay.
What'd you say?
Okay.
Can I eat my fruit?
Can you tell me another function that you can take the derivative of to get x squared?
Okay.
If you can, you can eat your grade.
Okay.
Oh.
Wow. It's storm.
I don't understand.
You guys are like actually thinking about this too much.
Thanks.
Well, yeah. you're
Does it
right.
make you more mad that Pika has it already?
No, it's
No.
good for him. I'm glad that he can do it. Because I can't do it.
You can do it.
I cannot.
Have you?
Coefficient
Yourself.
You can't do it. I can't get without a coefficient. I just can't do it.
doesn't have to change.
The little engine could say that. I have to say, I think I can. And then you
I
do
think I can, but I know I can't. There's no.
Anybody else?
Is it a whole different function? Is it like pretty much the same thing? Okay.
The second thing you said.
That's fine.
Let's take pi. Whoops, sorry. That's not what I want. Sorry, calm down, moment. Does that have a derivative of x squared?
Oh, what? That's what he just wrote on my paper.
Does that have a derivative of x squared? So, no matter what I add or subtract to it, when I go to take the derivative, what's the derivative of that part? Is nothing. So yeah, so then we put a plus c to indicate that I don't know if it's 1/3 x to the third, or 1/3 x to the third plus 10, or 1/3 x to the third plus a million, because all of those things would have a derivative of x squared. So that's explaining the plus c. Let's go through and do 2 and 3 together. I'm going to rewrite this first because I don't want this fraction here. So actually it's still lowercase f. So lowercase f equals 5x to the third plus 6x to the negative third minus 1. Notice what they're doing with the lowercase and the capital here. So they're telling you you have little f, find the antiderivative capital F. So when I integrate little f, I'm getting capital F. Or when I take the derivative, I'm getting capital F. So follow your rule. Add 1 to the power. So the new power is 4. And then you multiply by the reciprocal of the new power. So you're going to multiply by 1/4. Well, there's already a 5 there. So what's 5 times 1/4? Usually 5/4. Usually. Does that part make sense? So check it if you want. Take the derivative. What's 4 times 5/4? Will give you the 5. Then reduce the power by 1. Alright, if I do this on the next one, I'm going to add 1 to the power. So what's negative 3 plus 1? Don't say negative 4, please. Negative 2, thank you. Multiply by the reciprocal of the new power. So what's the reciprocal of negative 2? Be negative 1/2. Multiply by the 6 that's already there. We're at negative 3. Check it if you want. What's negative 2 times negative 3? Is 6. Reduce the power by 1 and we're there. And then what is this? Can think about the rule for this, but I don't know if most people do. What did I take the derivative of if I ended up with negative 1? Negative x. So that is kind of the rule. If you want to pretend negative 1 is really negative x to the 0, because anything to the 0 is 1. So then add 1 to the power, makes it a 1, multiply by the reciprocal of the new power, so negative. So it still works. But my answer's not done. And every year, literally every year, there'll be like 2 or 3 of these on your gateway. Someone will turn it in like that on all 3, let's say, and then instantly you got to C minus. Because what are you forgetting? Plus C. Like, I'll even walk around during the gateway and be like, I don't want to see any stupid mistakes. And people still, like, forget it. So just be, like, very careful about that. Alright, number 3. So I'm going to rewrite. So that's x to the 1/2, right? And then that it will be x to the negative 1/2, because it's x to the 1/2 on the bottom, and I'm going to bring it up top. Okay there? Then do your rules. If you haven't tried it, try it right now. Like, if you did the notes, you already did it, but if you didn't, give it a shot. Want to see anybody forgetting anything? It's not good as jokes.
Oh my god.
He was so excited. I know. It's not like I'm saying they can say it. Keep doing it. No control. No control. I'm so sorry.
Only I can control my feelings.
Exactly.
Experience.
No. Alpha male mentality.
Am I good or not yet? Not yet. Did you watch the notes I got? Because the plus C was like in there, I think, and I was just wondering if that's how you. So you knew the plus C, you just didn't like connect it, yeah.
So
I also
maybe,
had that on my
not
paper.
watching the notes and like being.
Yeah, let's not jump to that conclusion. Okay. So, add 1 to the power, so that becomes 3/2. And this is why I say, like, multiply by the reciprocal. Because, like, the way they set it up, you would divide by 3/2. But then I have a fraction within a fraction, and that's just a mess. So it's way easier to me to just multiply by the reciprocal. Because now I don't have to change it. And then add 1 to this power, so that'll be a positive 1/2. Multiply by the reciprocal, so I'm multiplying by 2, so this becomes plus 6x. Again, if you turn it like that on the gateway, there's no partial credit, you will get it wrong. Like, you just lost 10 points because you forgot. Plus C. It could be minus C too, right? Like, it doesn't really matter. There's a constant there. Whether you want to say it's plus or minus doesn't really matter. Questions on 3? Alright. So think back to trig, the trig derivatives. What did you take the derivative of to end up with sine? Because we're going in reverse. What did you start with if you took the derivative and ended up with sine? Negative cosine of x plus c. What did you start with if you took the derivative and then ended up with cosine? Sine of x plus c. So all those things that you had before, they all come back. We just do them in the other direction. All the trig and inverse trig, those derivatives, we just do them in reverse. But like not all at once, we slowly add. Okay. This is another fundamental theorem of calculus. There's 2. Very similar. So, I don't know how he wrote this out, but I'm going to write it out how I think about it. Capital F is the antiderivative of little f. So when I integrate little f, I'm going to get capital F. I got these brackets around it, and then I'm going to put A and B. Sometimes you'll see, like, instead of the brackets, you'll see, like, f of x, and then there'll be, like, a bar, and it'll say A and B. To me, that, like, looks confusing, so I like these brackets, but it's kind of up to you. And then what you do to calculate is you plug the top in, minus, you plug the bottom in. And that'll give you the actual area underneath the curve. We're not estimating with Riemann sums, we're not guessing, this is like the legitimate, actual correct area. So if I want to do number 4, so you might have wondered why I didn't put a plus C there. I'll try to talk through and show you that here. So when there's numbers here, that's called a definite interval. If notice like 1, 2, and 3 didn't have numbers there, right? Those were indefinite integrals. So indefinite integrals is when you need the plus c. Definite integrals you don't, because when you plug in, the c's will basically cancel out. So let's go through and I'll do it with the c, and then I'll show you why you don't need it. So I'm going to integrate that. So what's the integral of 4? 4x. So it's just what did I take the derivative of to get to 4? So 4x. And then you can use the rule here if you want. So add 1 to the power would be 2. Multiply by the reciprocal, so you multiply by a half, and you have 4x minus 3x squared. If you want to check it, take the derivative, and you will end up with what we got there. I'm going to put plus c. I don't need it, but I'm going to put it in there so we can see what happens. Because I got to integrate the 4. So what did I take the derivative of to end up with 4? This 4x. You with me? Okay. So then I've got -2 and I've got 5. So my job is to plug in the top minus plug in the bottom. So I'm going to plug in the top minus I'm going to plug in the bottom. So it's always that order. Plug in the top, minus, plug in the bottom. I'm going to write that out. Plug in top, minus, plug in bottom. I don't really care what the numbers are. Like, I know you guys can figure those out. But what I want you to see is when I combine these, what would happen to the two C's that are in there? They'd go away, right? Because I have a positive C here. And this negative sign means this C is negative. So these C's don't really matter. So in a definite integral, which is when you have the numbers here, you don't need to write the C there because it would just end up canceling out. It's not that it doesn't exist. It's just like not necessary. And then you can figure out those numbers. That's not really what I want to use our time to go through. But questions on anything except like simplifying? Where did you get this? What do I do here? Alright, so if I looked at 5. In 5, I would just rewrite it first. So that's x to the 1/2. 1 over x squared, how should I write that? You need x to the -2, yeah. Times my dx. Then I'm going to integrate, or take my antiderivative, so that's add 1 to the power, multiply by the reciprocal of the new power. The new power is 3/2, the reciprocal of that is 2/3. Over here, same thing, I'm going to add, like I don't put a plus or minus sign because I'm not quite sure what it is until I do this calculation. So I just add 1 to the power will be -1, multiplied by the reciprocal. The reciprocal of -1 is still -1. Times the negative that's out there is a +1. And I could put plus c here, but I don't need to because it's just going to cancel out. So I'm just going to skip it. Like no one ever writes it. I was just showing you why no one ever writes it. And I would get that. Question on that stuff? That's the integration. That's the calculus. So then you plug in the top. Minus, plug in the bottom. I'm not going to simplify this whole thing, but I'll do one more step. Just to review like the fractional exponents. Are we good up to here? Plugged in the top, minus, plugged in the bottom. So 4 to the 3/2. Sometimes you guys have trouble with this. So the one on the bottom is the root. So the second root. So what's the square root of 4? It's 2, and then you raise it to the power on top. So what's 2 to the third power? It's 8. And then 8 times 2/3. So it's like 16/3 plus, what's 4 to the -1st? It's 1/4. So it's 4 to the 1st, then flipped over. I'm going to make a mistake here. So be careful, just watch me. Like on purpose, I'm telling you. I'm gonna make one. So what's 1 to any power? 1 times 2/3. It's 2/3. And then what is 1 raised to the first power and then flipped over? Still 1. That is a very common mistake that people make. What did I just do? Yeah. So these brackets here are essential because if you don't put them, that is a positive 1. But with those brackets there, and aren't I going to end up actually making that a -1? The negative's outside the whole thing. So you have to make sure you're doing the whole top plugged in one set of brackets minus the whole bottom plugged in the next set of brackets. And then, like, on a free response or on the gateway, you can just stop right there. Multiple choice, you have to figure out the fraction. But I'm not that worried about that right now. Is that what you were going to ask?
I was gonna say, could you even have to take it down to that bottom step on the gateway?
You got to do you can leave addition, subtraction, multiplication, division. But this has powers. So you got to get rid of the power. Or if there's roots or trig, like it does. Questions on 5? 6. So 4 sine of x is written fine. This is that rule. I can take that 4 on the outside. Let's do it that way. So some of you might be like, I don't know how to integrate 4 sine of x, but I know how to integrate sine of x. So we're allowed to like factor out the 4. Do all this, and then multiply everything by 4 at the end. So what is the integral of sine of x? Meaning, what did I start with to take the derivative and end up with sine of x? Negative cosine of x. And I'm going from 0 to pi over 2. So I'm going to have 4 times negative cosine of pi over 2 minus, it's actually like, should be like squigglies. So there's brackets there. Minus negative cosine of 0. But then all of that multiplied by 4. Do you see what I'm doing? We okay? We're on the same page here? Or not? Okay. And then, so cosine of pi over 2. So 90 degrees. What's the x value at 90 degrees? 0. Minus negative cosine of 0. So cosine of 0, what's the x value at 0 degrees? Is 1. Then it's negative 1. But then it's actually minus negative 1. So it's plus. So it should just be 4. How's that one? Yeah.
Why do we not have to integrate the x? Why is there not a chain rule as well? Like it's on 2 and the actual work is something similar to that. You know what it says there?
Yeah, so you're saying why isn't, let's do cosine because the integral is just positive sine. I think you're saying why isn't it sine of x, like 1/2 x squared?
Yeah.
Well, test it. That would be my response. So what would the derivative of sine of 1/2 x squared be? It'd be cosine of 1/2 x squared. And then you multiply by the derivative of this, so now you multiply by x. So you just don't end up
Yeah, okay, yeah.
where you started. Is that a sufficient answer? Okay. If you're asking like theoretically why, that's a little bit above my. Alright, I don't want to do 7 yet, because I want to give you guys some time to start before you leave, so you can actually practice. So we'll spend 2 days on this. So you guys should do just do 1 through 6 right now. And then we'll worry about the next part tomorrow. So I want you to work on 1 through 6.